Hello everyone and welcome back to another Nevron engine development log. During these past few weeks I have been implementing Quaternions into my game engine. Quaternions are a really good way of describing rotations in 3D space. They are easier to use when interpolating between two angles rather than using Euler angles, which is what I've been using before, as they can produce weird results and also have a problem called gimbal locking. Quaternions fixes all of those problems and allow an easy way to apply the rotations as well to a vector. Adding two rotations are also a lot easier to do rather than using Euler angles, which uses a pair of three fixed axes in which it describes their rotation about, formerly known as yaw, pitch, and roll. Meanwhile, Quaternions describe rotations more in the way of an axis in which the rotation occurs around. To add two angles together using quaternions, you treat them as a four-dimensional complex number and do normal parentheses multiplications as you would do with any complex number. The only difference here being that it's four-dimensional, so you need to use both I, j, and k as the imaginary parts, which are most commonly known as the x, y, z components of the quaternion. Meanwhile, the real part is known as w. Implementing all of this took a long time because I've been so busy with school, and that I've also had to learn all of this myself, as I do not have any degree in math whatsoever because I'm only in 9th grade so far. At first, when I started with learning quaternions, they seemed like something from hell and not intuitive in any way whatsoever. Now though, they seem like a blessing from God himself. You really just need to sit down and do the math for yourself and you will be much better off. As someone who really likes math, it's an experience itself seeing how neatly and intuitively they multiply. I have implemented quaternions into my own math library that I'm making, as well as in the shaders, so that I can use them as is and do not need to convert it to some kind of a rotation matrix. It would have been a lot faster and saved me a lot of hassle if I would have been to use an already existing math library, like DirectMath for example. But I have decided to make my own math library because that way I get more control and can implement functions as I wish and need. Plus, you really just learn a lot more on how the game engine is and gets a lot better understanding of how it is from the ground level. So I thought I'd show you how it looks inside of the game engine. So I have now created a bunch of random boulders and I have assigned each of them a random angular velocity in which they will rotate in. So let's see here if I can show you. So as you see, all of these boulders rotate around with their unique rotation. And as for now, the rotations work perfectly and there are no problems whatsoever with them. And this is much better than what I had before using the Euler angles, because they are a lot more tricky to use, as you need to convert them to a rotation matrix every time you need to use them, which also means that the quaternion is easier to use once you have implemented it, because you do not need to convert it to anything, so you can more easily control rotations. And this is a huge bonus for me, as I can now start implementing reactions for things to start rotating when they collide, and that is what I will be doing next time. And until then, happy coding.